A very good afternoon to all. Tamil?
Good afternoon, ma'am.
Okay, we will start.
Okay, ma'am. Okay.
Okay.
So, good afternoon to all once again. So now we are going to have a look on. I will give you just on what is how inception model works. Then we will go on to the basics of CNN architecture and some of the popular model implementation and visualizing CNN. These are the three aspects we are going to cover. The fourth aspect, or I can say that the current trend in the deep learning is fast AI. I will give you a gist. If time permit, we will have a look on it. Okay, or else you can get the things from the internet. I will give you just how you have to work on it. It is very simple. There is no need for large amount of coding here. That's why the name Fast AI is here. It is released in the recent days only. So first I will start with some insight into inception model so that you will get a clear aspect. Then implementation is very simple. If you are clear with the one model, then other models are very simple. I hope my screen is visible for you. I will give you an insight on it. This is what I want to give you a thing on it. See here, the core building block, how we have told that, right? Hope I am audible for you and my things are good for you. Okay, from my side, I think if there is any interruption, kindly inform me. So I have already told that how sigma neuron is a basic block of the neural network. I mean deep neural network. Here inception module is the core. I can say that the building block of the Google net. So Google net is nothing but a series of inception model along with convolution and other layers. The main drawback we are faced in the AlexNet or VGG is that because of depth, higher depth is nothing but we are moving for more number of filters. If you move for more number of filters, you have a more parameters. If you have more parameters, then computation is more, so it becomes computational intensive. So in order to avoid that only, Google has introduced 1x1 convolution. With 1x1 convolution, you are able to reduce the width of it. Hope we have seen this, right? So in this previous slide, we have seen this one. So instead of having 192 depth, we are having 64 cross 64 into 1 only. I will give you a calculation so that you will get the things out of it. See here, I'm going to, this is the inception module. You can apply for all these things. I will give you an example for a minute on this. So for instance, I am doing, instead of doing the direct convolution, first I am going to reduce the depth. So I am going to have 128 filters. In that, I am going to perform 1x1 convolution. When I perform 1x1 convolution, my original thing is that volume is 28 cross 28 into 256. Then how it will be reduced? 28 cross 28 into 1. Am I right? So because of 1x1 convolution, this will be reduced into 28 cross 28 cross 1. We have seen this. This is what 1x1 convolution. Since there are 128 filters, you will have 28 cross 28 cross 128. This is what the output of this phase. Similarly, you have done this. So you will have, because of 1x1 convolution, you will have 28 cross 28 into 1. So and you have 32 filters. So that's why 28 cross 28 cross 32. Next, what I am doing max pooling. Please make a note of it. I am going to maintain this height and width. I am not going to change any thing with respect to height and width. So always please make a note of it. And I am not going to reduce the image size. The main aim is that I want to reduce the depth. It is not that I have to reduce the image size. Always maintain the image size what we are maintained in the previous state or the previous state. We have to take the input for this inception model. So the next one is max pooling. If you go with the max pooling, what will happen? So 3 cross 3, if you go with the 3 cross 3 max pooling, it will be reduced, right? So in order to overcome only, we have used stride of 1 and padding of 1. Hope you know, if you have used stride and padding of 1, this is what the input to this module is 28 cross 28, okay, into this 256. Now you have gone for max pooling, 3 cross 3 max pooling. There is no parameter, but if you use S equal to 1, P equal to 1, substitute those in W naught and H naught. You will get the thing. Because of stride and padding, you will get the same thing. Because of pooling, what will happen? It will be reduced half, right? 14. But because of that padding, because it is 2P, right? Because of padding, you will get the things. So you will get 28 cross 28 into 256. Next one, you are going to have 1 cross 1 convolution. You are having 96 filters. So the width as usual, 28 cross 1 into 1. You are having 96 filters. That's why 28 cross 28 cross 96. Next, I am taking this as an input. See here, 28 cross 28 into 128. And I'm going to perform convolution with 192 filters. In this case, in order to retain, if you go with 3 cross 3 convolution, always there will be a reduction in size because your kernel is 3 cross 3, the corner cells will be omitted. Because of that, what you have to do, you have to go for padding. So this padding is 1. Since S, you cannot give it as S0 because denominator, if it is 0, it will become an error, right? That's why. So by default, padding is 0 and S equal to 1 in all operation, if not specified. If the things are not specified, the default is stride equal to 1, padding equal to 0. So here I have given padding is equal to 1 in order to avoid that. So I have one row in the top and bottom, one column in the left and right in order to accommodate the corner cells. So as usual, 28 cross 28 is maintained here. But here, since there are 192 filters, you have 28 cross 28 cross 192. Now I am going for 5 cross 5 convolution. So and there are 96 filters here. So since there are 5 cross 5, you can note that 2 cells will be lost, right? So in order to avoid that only, you are going for padding. Then stride as usual 1. Kindly substitute it and check for it. If any issues, I will address that. I have checked that and it is working fine. So as usual, 28 cross 28, 96 filters. Always make sure that this inception model will reduce only the depth, but not the width and height of it. So the reduction in depth is not with output. Before performing convolution, because only the convolution layer, only there will be more number of parameters. We have seen that, right? In convolution layer only, more number of parameters are there because parameter is directly dependent on the width of it. So before performing convolution, if you reduce the width of it, the number of parameters will be reduced. So that is what the thing that is done in the inception layer. So the next one, 96 1 cross 1 convolution is done after that. Since 1 cross 1 means you will get 28 cross 28. If you perform this is 96, if you give the input as 28 cross 28 into 256 will be the input to this. When you give the input to this after 1 cross 1 convolution, the output will be 28 cross 28 cross 1. There are 96 filters, so now the volume will be 28 cross 28 cross 96. In this case, if you add 96 plus 192 plus 96, 96, you will get 480. This is going to be, now see here, 28 and 28 input and, input is preserved with the size, that is width and height. They have performed n number of convolutions and max pooling. If you go and check with the convolutions, here there is no number of parameters used for this convolution. Surely it will be reduced compared to that of the VGGNet. So this is how Google has come with an innovative thing in order to reduce the number of parameters. So before performing convolution, you are going for 1 cross 1 convolution. So the depth will be reduced. Then you are going with your original depth or reduced depth, whatever the thing you want. So this is how the things are done in the inception layer. Hope you are clear with these things. I hope so. We will start with our hands-on session. So hope this is visible for you. So first, as a first part, we are going to have how CIFAR10, this is curated dataset. I am already saying this is curated dataset, CIFAR10. in the ImageNet data set. Then you are going to use the data loader. Then we will have a visualizing how the images are there, and we will have a single convolution layer and multiple convolution layer. You can stack on your own. As I have already told, that it is not that you have to use a predefined model. You can stack the layers in the model using the sequential method present in this model. You can go ahead with it. This is how the research thing has to be carried on. Or if you are very good with your data and very good with your network, if the network is working fine for you, you can go ahead with the hyperparameter tuning. This is how the research can be carried out. So in terms of CNN, the things are vast. Am I right? Data is there. Everything can be done. In deep learning, everything can be done. Only thing is that you have to find the application. So based on application, you have to choose whether I have to go for the predefined model, or I have to stack my own model. Then based on that, hyperparameter tuning is the most thing. I can say that 75% of the result is based on hyperparameter tuning, like number of filters tried, kernel size, and other aspect. Even here, 1x1 convolution in here, the number of filters plays an important role in the inception module. Next, you are going to have a thing on LeanIt, then going with how it has been updated to the GPU instead of CPU, then simple visualization. This is basic. I'm not going depth in that, very basic thing. If we are clear with the basic thing, then we can go with the predefined architectures. So as we have already seen this, right? We have to import the torch. So this matplotlib is for plotting and numpy for calculations. So first thing, we have to load this, right? As I have already told this is transform. I will tell what this transform. If you are going with a pre-trained model, this transform plays an important role, very important role, I can say that. First, I have imported Torch Vision. For image itself, they have provided a library called Torch Vision. In that, there is a something called transforms. In Torch Vision, you have n number of data set. In that, I am going to take CIFAR dataset, CIFAR 10. 10 means you are going to have 10 classes. CIFAR 10 means you are going to have 10 classes. If you want to have a look on this URL, you will get the things out of it. So in CIFAR 10, you will have, I think it is 50,000 image. It is divided into 5 batch or 10 batch, I think so. I divided into 10 batch with 5,000 images in each batch. So this is, and here root equal to dot slash data means, in that, see here, in the data, see here, CIFAR data things will be downloaded. So this is what, if you root current working directory in that data folder, it will be downloaded. I will tell you what is this batch and zip file things are. Next, train equal to 2. Yes, you have to go with the training thing. Whether you want to download or not, yes, download. Whether you have to transform this, yes, you have to transform these to tensor, because we are working with the PyTorch. So if you go with the TensorFlow, it is here also, there also, you have to convert this to tensor, then you have to work on it. Okay, even though it is PyTorch or tensor, you have to convert into tensor, though, so that you can work with it. So the next one, as I have already told, that in CIFAR 10 there are 10 classes. So classes, I am giving the class name for here. And the next important utility in the Torch is the data loader. So in data it is used to load our data. In that, first I am loading the training data. See here. If you unzip this, you have a training and testing. So first, as of now, I am going with, see here, it has already extracted and these things. Here I am going to have a train set of batch size 4. It means that I have divided into number of batches. In each batches, we are going to have 4 images. Just for our computation, it will be easy to run, right? That's why. Then shuffle. If you want, you can shuffle and give. For each iteration, you shuffle and give the images. So if you run again and again, you will get the different images. So the next one is data iter. So this is one utility, very important in order to load the data set. So the next one is iter. This is also another thing. This iter function will help you to load the things, load your training set, and in order to iterate next to next. Okay, if you take the list, you give next and next, you will get the things like that. In the data set, if you want to iterate it, go with the iter. So in the iter, this is going to return in the data iter. This will return image plus labels. So you can get the things again and again. There is no need for for loop because iter and next will take care of all these things. Or else in manually, if you want, you can go with the for loop. If you go with the for loop, this is not a Python programming. This will become a C programming. So mostly we have to use all the simplified versions of the Python thing so that the number of ports is reduced. If you now go with a fast AI package, even more, within 10 to 15 lines, you can get the things out of it. This is how it is being done. Mostly it is done for mobile deep learning too. So this is what the thing. If you print this images dot shape, see here, I will write run this so that you will get. After execution, you are getting the output, right? See here, images.shape, it is giving that it is 4, 3 to 32, 32. Here 4 is nothing but a batch size, 3 is nothing but a number of channels. Since this is a color image, so you have RGB, so 3, and each image of size 32 cross 32. Are you getting the point? So this image is nothing but a list. In that list, this is the shape of shape of the list. It is nothing but this is the size of the list. You have 4 4 batches. There is 3 channels, each of thing 32 cross 32. Next, if you take one of it, if you take one thing out of 4, you are taking one thing. So the size of it will be 3, 32, 32. If you want to print the item in that, it will give you the 9, which is nothing but a label. Label here is nothing but what is the label associated with it. As of now, we have not correlated the label and other things. So here 9 is nothing but I think it is ship. So this is the pre-processing done in order to extract the data from the Torch Vision datasets. So there are many things available. Go and have a check on it. This is a well curated data set. For learning purpose, you can go ahead with that. So if you want your own data set has to be given, just remove this. Instead of Torch Vision data set, you have to give Torch Vision your own data set. You have to give it as upload. That's it. Only changes if you want your own data set, custom data set has to be given. Instead of that, you can give Torch Vision upload data set instead of going with these things. Then as usual, you can manually upload the things in the data folder. You can access these things. Same thing. If you are not going with the predefined data set that are present in the Torch Vision. So the next one, we have seen data loader and data iter. These things are used to get the data out of it. Now we will visualize the data. So here image equal to image 1. The type of it is nothing but a tensor, as we have already seen this there. Now this is a tensor. In order to work on it, we have to convert this into NumPy. Am I right? So in order to convert the tensor into NumPy, which is nothing but dot NumPy. We have seen this in the yesterday class. The shape is nothing but 3, is there any issues? I hope. Yes. I hope someone has raised their hand. Is there any issues? Okay. So now I have converted this tensor into NumPy. It means that it will give you only the shape of the image. Already we know that the shape of the image is 32 cross 32 into 3. 3 means it is a colored image. If we go with the grayscale, it is 32, 32, 1. Always it starts with the depth, width and height. This is how this PyTorch will give you the shape of it. Next, what we are we need the things. So we are, even though we are tensor is giving the shape like this, but in NumPy we need that first one is with height and depth. So that's why we have transposed this. So this is 0, 1, 2. First you have 1, 2, then 0. That's why we have converted these things. So NumPy will work like this only. So now I have plot the figure. Hope you know IM show and show will have a look on it. This is what the image that we have taken from the data set. So next one, the same thing that is done. IM show is a default function in that plot library. Instead of that, you can override this in that. What you are going to see is that we are going to have a loop on it, iterate on it. IM show torch vision.util. You are going to make a grid out of it. In that, see here, I am going to give a class. I know the label for instance, label of 0 means here I have defined a class, right? In that class of 0 is nothing but a plan. Class of, if you can get the index, right, from this you can get the index. See here, label of one dot item. If you give item, you can get the, because this will acts like a dictionary, you can get the index of it. With that index you can map to the class and get the label of it. Okay, so I have done this in the inline function. See here, space join classes of label of j for j in range of 4. So I have make a grid. In that I am going to have a display of the images present. Instead of showing one by one image, just I have go ahead with the grid of images. That this is not a simple thing. We have visualized the thing. It is not that you can use a for loop and visualize image one by one. One thing is that you have to convert this into NumPy and you have to go ahead with that. If not, it will not work. Torch will not work fine for that. So next we will go to how to build a single layer. Then we will go ahead to build a multiple layer. For each execution, this will changes because I have given the shuffle equal to true. So for each time, this may varies for each execution. If not, you have to give shuffle equal to false. Okay, there comes our core part. So I'm going to import torch.nn. This is important module. I think yesterday, because of time constraint, I have left you a thing. This is an important class, NN class. This is a neural network class that is present in the torch that will provide you certain functions like forward, init. I think you have studied how to write a class functions in Python. So I don't want to have a repetition of it. So I have given a class. I have defined a user-defined class. This is a derived class. The base class is nn.module. So each and every class, it is not that you have to always inherit your user class under thing, but as of now I have inherited so that I can use the methods and constructors of nn.module class. So nn is an important library for neural network. It contains, for example, backward, gradient descent, autograde, all those functions are available so that we can use on it. So nn.module, hope this is a constructor. Hope you got the things because you have already studied how to write a functions in Python and how to define a constructor in Python. Then this is the super constructor. You have called the superclass constructor in order to have a look on it. So this is in that your base class is nn.module. So you have got it. So self is nothing but self is a pointer that is referring to that base class, or I can say that the current working class. So self.conv1 equal to self. If you give self, it is going to have a for this class alone. So nn.convolution2d, this is a method. So this method is already available in nn class. So object.class. Okay, nn.convol2d 3, 16, 3. Here 3 is nothing but you are going to have 3 channel for input, that is RGB. 16 is nothing but you are going to have 16 filters in this convolution 2D convolution. As I have already told that there is no 3D convolution, there is always 2D convolution. Here the depth here is 16. It means that there are 16 filters. We are going to have 16 filters and your input size is input channel is 3. It is meaning that you are going to have RGB, and here 3 is nothing but 3 cross 3 column. That's it. Okay, so output is nothing but you are going to have 16 output channels. So padding I have used, instead of 1 I have to give 1, 1 and stride up to in order to maintain the input thing. So then you will define a forward function. This will be called when you invocate this call this function. So this is instantiation. So this is instantiation. Then out is equal to net of this means this will call the forward function. This will call the convolution one. In this convolution one, this will call the convolution 2D image. This is how the flow of thing. See here, now you have instantiated, object is created. Once you get the object is created, this constructor will be called. In this constructor, you have called the superclass constructor. So this forward will be, there is no need to explicitly call the forward. It will be called automatically when you use this thing. So when you give output equal to net of image for x, this image will be passed, and for this variable, this image will be there, and based on this, these things will be done, and your convolution layer output will be produced with 16 channels. Okay, so can you expect what will be the output? So it will be 16 channels, each of size 16 cross 16. So okay, you will get the, wait, I will run this and we will have a look on it. So this 4, hope you know that this is a batch size. You know why this is 16 is nothing but 16, there are 16 filters, right? That's why 16. This is height and width. So with this padding and stride, and 3 cross 3 kernel, you are getting the output as 16 and 16. If you want, you can verify the things also. The original image here is 32 cross 32. Now it is being divided. Check with your formula and you will get 16 cross 16. Now we want to have the parameters. What are the parameters in that? If you go with that parameters, for param in net.parameters, what are the parameters? What is the shape of the parameters? That as usual 16. So you have 16 filters. The 16 here is filter. This is user defined. You can modify and check for not only 16 or 30 to 58. It is up to you. This is user defined. This is also user defined. If your image is colored, you have to use 3. If your image is grayscale, you have to give 1. Then these things are absolutely under your control. This is a hyperparameter tuning. You can set on your own and you can test on it. It is up to you. But this is based on inference, you have to give. If your image is colored, you have to give 3. If your image is grayscale, give it as 1. That's it. So you have to interpret the output, then only you will have a look on it. So in this parameter, there are 16 channels of 3 RGB is nothing but 3. So each of the kernel, this is how we will calculate the parameters, right? So the F is 3, right? 3 cross 3 is this with these 3. How many of you like this? 16. That's why. This is how you will calculate the parameters. Am I right? F into F into K into D. Am I right? Same thing that is given here. It is not up to our convenience. This is how this is producing the output. We have to interpret on it. Okay. Now I have taken a image out of it. See here out is nothing but I am going to get the thing out of it. Here the out is nothing but, see here, output is nothing but output of this first layer. After processing this, what is the output of it? So here, see here, I am going to take the first one. So this is what is size of it. So I'm going to take the output of first filter. Okay, that's why output of the first filter. And you have 3 channels, right? RGB. So 0, 1, 2. For numerical, I am saying that it is 3, but it will be indexed as 0, 1, 2. I am taking the 0th channel, 0 indexed channel, and everything, rows and columns as usual. Okay, so detach from this. Detach means you have to take out of it. As I have already told that it has to be converted into numpy. Now its shape is 30. Yes. Now its shape is that now you can now it is converted into numpy, which is a meaning that here the original image is 32 cross 32. Now it is being changed and it is being converted to 30. Then I have detached these things. I think detached. Then I have used I am show. In that I am show, I am printing this here. If you see here, you can see that this is what the output of the first channel of a particular image. This is how you can visualize the thing. After convolution, you are saying that there are 16 channels. Am I right? As per my first convolution, there is only one layer. After convolution, this is how my image is going to look. In a first channel, please have a look on it. In a first channel, because I have given 0 0, right? I have given 0 0 in that first channel. This is the pattern that convolution layer has learned in it. Okay, so this is how the things will be like this. This is the initial thing. So that's why you have a dense layer. For each and every layer, they're going to learn some pattern, and based on that pattern, they will construct the image. This is the starting stage with which you are going to get some patterns. If you go with the original image, so this is a car, I think. So this is the first one. In that, if you can see that here you can see some green colors are meant, I think, to see here this sunrise, and these things are in the same color, right? So some neurons will be responsible for this, that's why same color, and some neurons will be responsible for this red color. It is nothing but a color only, right? Some neurons will be responsible for this red color and other thing. That way you can see some edges in it. See here. So this is how if you go after convolution, this is how what happened in your image. Now if you apply more and more layers, more and more features are learned and it will be extracted, and this is how it is going to be with the image tag, either classification, reduction or localization. It is up to us. So this is how the first thing done here in the single layer. So now if you go and construct with the deep convolution layer, as I have already told, that it is not that you have to use only the already defined module, you can go with your own module. So in order to go with that, it has provided a function called nn.sequential. So you can construct your model. So self.model equal to nn.sequential. Mostly if any in GitHub or any publicly available in the internet, mostly they will go with this type of sequential modeling. Am I right? The number of layers will be stacked according to your application and it will be executed and gone out. This is how most of the codes in the GitHub or in the internet will be available. It is very rare to go with the pre-trained model and get the things out of it, because pre-trained model is a black box. If you are well enough to go with the pre-trained model and if you are able to change this is very good. You can change the pre-trained model also. So the thing is that if you know the internal working, if you should know this is how they, for instance, if I am saying that if VGG 19, it will accept only the image of 229 or 227 as the input. Those things you have to know and you can work on it. If you print the model itself, you can get all the things. But if you are not well enough to about the internal aspects of the model, this is the one way of constructing your own customized model. So first I have created two things. One is convolution 2D and two convolution layers. See here, this is 3. This is n3 comma. See here, n is nothing but a batch size 3 comma 32 comma 32. 3 is nothing but number of here it is number of channels. This is 32 cross 32. I have given. This is the input I have given. I think you are getting the point, right? This is 32 cross 32 image. This is how the image is present in the CIFAR10 dataset. And this is the RGB image. So this RGB image is have 3 channels. Now it is being given to a convolution. This is input, right? This is the input. Now it is given to a convolution layer. The spec of the convolution layer is that I have taken same batch 8. Then N8 is nothing but number of filters, then 3 cross 3 kernel. So this is nothing but a number of channels. This is nothing but 8 filters. If you give 3, it is nothing but 3 cross 3 kernel. So if you apply 3 cross 3 kernel, hope you know that if you apply the kernel without padding, if you have not given any padding or stride, the default padding is 0, stride equal to 1. So there will be reduction. If you has 3 cross 3 kernel, you will have a reduction of 2 size in your original, 2 units in your original data. That's why 30 cross 30. So this is taken 30 cross 30. This is taken as an input to this model. Okay, see here 8. Okay, this is taken. This is what the depth is, right? Since you have given 8 filters, that is going to be depth. So 30 cross 30 cross 8. So again 30 cross 30 cross 8. Here I have used 16 filters and the kernel is 3. Okay, if you have the input here is that 30 cross 30 cross 8, but your now you have used 16 channels. So because there is no padding and stride, now also your input will be reduced by 2. So that's why 28 cross 28. The number of filters here is 16. This is what the shape of your current output after 2D convolution. Hope you got the things right. This has to be clear. If you are clear only, you can write on this. Always please make a note of it. Whatever the output of this is going to act as an input for the next layer. Same thing. This is logically understood, right? So this is, you can ask a max pool layer and other thing. It is up to you. As a simple thing, I have started with this. Then you have to use forward. This forward will in turn calls the model. You have instantiated it by creating an object. Then you have passed the images. Then you have checked for the shape. We got the same thing, right? 28 by 28. Here this number of filters is 16. That's why 16. Batch size is 4. So this is how you have done here. Then I have plotted these thing. So by plotting after 2 convolution. Before that, we have seen only 1 convolution. So after 2 convolutions, my image has been, my things has learned something. This is what my feature map is. See here, this is what feature map. So based on some thing, it's after, this is after 1 convolution. This is after 1 convolution. After 2 convolution, you can see that it is able to have some narrowed down picture of it. This is how deep learning modules will learn the things. That's why you need more convolution layers or more epochs or more filters. So this plays an important role. You can ask, how can I decide that how many filters has to be placed? It is an experimental thing. That's why it is called as hyperparameters. You have to work on it. So if you have a number of filters, if you provide more number of filters only, it will so each and every filter will be responsible for a particular feature, then they will get out of it. So if you provide number of more filters, what's the problem here is that the number of parameters will be increased and your model become over intense. So the complexity also increases, and the other thing, computationally it becomes intensive. So we have to have a trade-off between the number of filters and also the execution time. So it is a trade-off thing, we have to work on it. So I have done another thing, which is simple thing. Just I want to know how, whether you have able to apply the things what we have seen in the morning session with the things. Same thing. So I have 3, hope you know these things, right? 3 is nothing but RGB. As of now, I am going to go with 6 filters, 5 cross 5 kernel. So with this, you can say that 6 filters as usual, since there is no stride and padding. So you have, there will be a reduction in your input data. The input data is already 32 cross 32. If you give 5, 4 will be reduced. Am I right? That's why 28. Then you have gone for average pooling. Here the thing is that in average pooling, you have used a kernel of size 2 cross 2, that's why 2. In order to retain the, you have used the stride of 2. So the stride of 2, after calculation, you will get that 14. So this N6 28 20 is taken as an input. Check for it. You will get the same 6 filters. There will be a reduction in the thing. Next, I have constructed another convolution layer. The input here is with 6 filters. but I have used 16 filters of kernel size 5 cross 5. If you don't use padding or stride, if you have given 5 cross 5 kernel, 4 will be reduced. So 14 minus 10, minus 4, it is 10. Again, this is given as an input to this average pooling. So I have already told that there are max pooling, average pooling. So I have gone with average pooling. The kernel size is 2 cross 2. Stride is given as 2. Always go with, apply the formula. W1 equal to W0 minus F plus 2P by S plus 1. Same thing, always apply. That's it. So you will get 16. This is what the 16. The input is given as 16, 10, 10. So N 16, 10, 10. The output is 16. Because average pooling, there is no filters and other thing. Then because of this, there will be a reduction in size of 5 cross 5. So as usual, forward function is returned. Then you have instantiated it. Size, hope you got the things out of it. Hope you are clear in this size. That's why I have given you an explanation on that so that it will be clear for you. Mostly you will get an error if you download a thing from the GitHub or the internet. If the parameter, I can say that if the shape mismatches, you cannot get the output. So kindly learn always, if you are writing the code in a sequential manner, always go with this practice. This is a good practice of stacking the layers in your deep neural network. If you are going with 100 to 200 layers, for instance, if you want to create a model like ResNet, this is a good research work too. If you want to have a good model like that of the ResNet, for instance, if you are writing 100 to 100 or 150 layers in that, so it is very important to have things like this. Then only you are able to trace and work out of it. So this is what the thing out of it. After construction of this version 3 deep neural network, you can see that because of average pooling, you can see here, because of average pooling, what will I cannot have the things minute here because I have averaged most of the nearby neighbors. That's why I'm not getting the particular out of it. If you go with the max pooling, it is very different because you're taking the average maximum feature that is contribute to your image task. So if you go with the max pooling like this, sorry, average pooling, this is how you will get the things. So initially they will identify only the patterns. Then layer by layer they will identify the patterns, then will go into the image. Not in a first stride itself, it will not go into the image itself. So we have constructed a LeNet here, same thing. I have given you a deep explanation on that. If you want, you can work on it. So this is convolution model, and hope you know that LeNet has convolution model and fully connected model. Hope you have gone, we have seen this in the, I think we have seen this AlexNet, right? So LeNet will have the same thing as such of the AlexNet. You have a convolution thing, then you have a fully connected thing. So I have already told that for image classification, TANH is an important thing. Okay, TANH plays an important role. That's why we have gone with, because you know that there is an activation, pre-activation and activation. For pre-activation is nothing but aggregation, right? Activation is nothing but you have to apply some function. Here the function is TANH, that's it. You can also have a TANH in this also. If you want, you can activate your output with the help of TANH. It is also allowed. This is how in LeNet, most of the network will have things like this. We will visualize these things. Then as usual forward, in that forward, first you have to have the, call the CNN model, then only you have to call the fully connected, because our architecture is like that only. Convolution model, then fully connected model, because the output has to be flattened, right? So that way fully connected model. We have seen this, right? We have seen this into reshape, because in convolution model you need a vector, right? Now, rather than that of a scalar, rather than that of the 2D matrix, you need a vector. This reshape is done with the help of this. Okay. So as usual, if you instantiate this with the help of a object, pass the object, then forward will be invoked. In that forward, first CNN model will be invoked, then FC model will be invoked. So this will print you the thing. So see here, this is nothing but a softmax of each and every layer. Since we have 4 batches, right? So if you want to print the output of this, since we have applied this by default, this will apply softmax. FC model by default, this will give you the probability mass. If you see here, each and every model will give you the probability mass for each and every classes. Since there are 4 branches, you will get the thing. And now what I have done here is that in this each class, I'm taking the maximum value. So I am taking the maximum value, and what is the class associated? For instance, this is the maximum value, this is the second class. If this is the maximum value, this is the class associated with this. This is how I will get the thing, and this will be returned as, and the index will be returned. Based on this index, I can go with what is the label associated with this. This is how image classification has been done. So for a small sized batch. So we have done this here. So LeanIt is simple thing. So that's why I have not taken this. Is it become absolute. So so now it is not being used for any image classification, but this is very simple. This is the internal architecture of the thing. We have implemented it. So next one, if you want, so this is what these were the class. So next, if you go with the training, you can go with how we can train this. As usual, we have the LeanIt classes. See here, as of now, I have gone only with the small batches and other thing. Now I am going to have a thing on how to train the model. So in order to train the model, 4 images are not essential, right? Just I have evaluated the thing, whether it is working fine or not, just with the probability mass. Now only I am going to the real thing. See here. So you have to divide this into train set and test set. In train set, as usual in CIFAR, you are needing enough training data. You have to take these things from training data and you have to download this transform. Hope you have seen this, right? To tensor, right? Then you have to have a data loader in order to get the data in the form of rows and columns. So this training set, batch size is what the size given to you, and then shuffling. Then in test data, if you want, you can, this is not for training, this is for testing. That's why you have to give it as false here. Okay, then as usual test loader, if you want to go with the shuffle, if not, doesn't go with the shuffle. Now your data is divided into 128 batches. Okay, in that you are going to first you are going to divide your data into train data and test data. In that train data, it is divided into batches of size 128 each. Next, what is next is going to here, you are going to have predict the accuracy for that. So total and correct we have taken. So for first you are going to iterate in the data loader. See here in the data, I have not called the evaluate. Once you call the evaluate only, this will work for her. This evaluate function will take the data and input and labels. This data will return. Since the data will have the input and labels, output is nothing but you are going to call the network. So this output, what this will return in the output, what it will be returned is that probability, that is probability mass. Okay, probability mass will be that. Along with that, if you want, you can go with the index. Am I right? We have seen this, right? If you want, you can go get the data and also the index. Same thing. I am going to find the maximum out of it, and that is what the predictor. And I'm going to have total equal to total plus label dot size of 0. So this is nothing but I'm going to tell how many of them are correctly predicted, and I am going to sum of it and I am going to return this. So accuracy is nothing but correct by total. That is how done here. So now I have created an object for LeanIt. Okay, so once you have created object for the LeanIt, see here, this forward will have this. If any constructor is there, that will be instantiated. Then if you give the forward, this CNN model and FC model will be, forward will be called automatically. There is no need to call forward explicitly. This will be called. Then I have used optimizer, right? We have seen yesterday many optimizers. Am I right? We have seen many optimizers, right? So one of the optimizers is Adam. For loss function, I have used cross entropy because I am going for probability. If you are going for probability, it is best to go with the cross entropy loss. So we have seen many formulas like y minus sigma into minus summation of y log I, y hat, y log y hat is the formula for that. We have derived many things. Simply if you give n dot cross entropy loss, that is enough. We have seen Adam, right? So for Adam, you are going to give your parameters. This will take care of all the things. So if Adam will have a look on how to prevent the vanishing gradient, right? It will take care of vanishing gradient in such a way that it will have the update of its. So this is the my optimizer. So these things are present. This Adam is present in a torch.optim. I have created an alias name for that. This is torch.optim. Then I have given the magic function in order to find what is the time for it. The next thing I think I am going to push it into the GPU. That's why I have given you how this is working. So next what I have done here is I have created a list on it. I have run this for 16 epochs. Since this 16 epoch itself take more time because this is running on GPU and you have 50,000 images and these 50,000 images are divided into a batch size of 128. So surely it will take time. So I have taken the data. See here, I have gone with a zero grad. So what is the use of this zero grad is nothing but zero gradient. See here, this is optimizer. If zero grad is given that initially it is done with a zero gradient, then it has to optimize with a step function, increment it. Okay, this is what the thing. Then I have called the method, then loss function. Hope you know this is after calculating the loss, you will back propagate. Am I right? You will back propagate it. During the back propagation, what you will do, you have to go for optimization. During back propagation, simple thing, during back propagation, you will have a derivative, partial derivative. If you do partial derivation, if any of the things is constant, this will become vanish. So in order to avoid that only, you are going for some of the optimizer like Adam, Ada, Gray and other thing. So here step optimization is nothing but gradual improvement, not the exponential improvement. Then you have added this item into the last array. Then last epoch array is also updated. We will see these things. Then you have called the evaluation here. This accuracy will be printed here for this epoch. This is plotted here. See here, I have given total for 16 iteration. This text accuracy is 38, whereas the training accuracy is 38.7. More or less, they are now trying to learn. Hope we have seen this in the feature map, right? So after convolution, they are going to have more or less same thing. If you give average pooling only, the things will be different. If you are going with the same, more or less same conceptual thing, training and test will be more or less same thing only. So this will take a while. So after execution, you will get the things out of it. So this will take a time, right? In order to avoid that, we are going to move our content to the GPU. Hope you know how to have set your day working environment to GPU in edit. In notebook setting, please enable the GPU. That's it. It is not that if you enable the GPU, it will work on GPU. It is not that. You have to write the code for that. Same code, only thing. So I have done an inline function here. Torch.device. First you have to initialize write this device, right? Instead of CUDA, I have given it as a device now. If torch.CUDA is available, you give the name as CUDA0. If not, you go with the CPU. Okay, now your device may have either CUDA0 or CPU. That's it. The value present in the device may be either CUDA0 or CPU. If you have not enabled, you will get the CPU. That's it. So same, whatever I have done here, same. Only thing is, see here, in the input, I have to push to this too. I have to push my input to the device, I mean GPU, and also labels to my device. These are the changes I have done. Everything, remaining things are same. See here, in this thing, See here, input comma labels equal to data. I have given right. See here, since this is working on the internal environment, same thing. Next, I am instantiating input and label to the inputs that are pushed to the device and the labels that are pushed to the device. Remaining things are as usual. Then I have created an object to the linear. Now the my model is also in the GPU. Since my data is also in the GPU, I have to push my model to GPU, right? That's why to device. Then as usual, cross entropy optimizer, same thing. If you observe these things, if whenever you have the data and label, you have to push on it. That's it. So this will for 16 above, this will work fine, and it will take a smaller amount of time. Then I have printed this test and training accuracy. So this is taking time. So these are basic visualization. You can make a thing on that. How this image will looks like after that, after passing the data into the ImageNet. Okay. So now you have converted, you have moved to CPU instead of GPU. Now you have moved to CPU. Then you have done some process. That's it. What is the shape of it? What is the thing out of it? You can visualize the thing. Now see here, after pushing that, see here, after pushing the things, after pushing your data onto the GPU, you have performed some operations, right? You have instantiated the linear and it has returned the something. Now you don't want to visualize the things from the GPU. Now we want to shift to CPU. That is what the thing you want. This is the original image. This is the original image. Next, I have moved from GPU to CPU. Now see here, net to CPU. Now my model is moved from GPU to CPU. Then I have taken the image out of that. I have printed the shape of it. Then see here, I have taken the one image and I have seen how it has been learned. So see here, it has learned something, right? Most of the features it has learned. And if you go with the fully convolution layer, more or less under layers, it will work fine for that. Okay, if you go for more number of epochs or more number of filters, then you will get a fine grained features. Then you will get the correct classification. This is what the image that is, I can say that this is what the feature map that is given by the linear for the above configuration. The configuration is this CNN model, this one, CNN model, FC model. For this configuration, this is the output given by the linear model. So in order to improve that, you can make changes either in the number of epochs or changes in the number of filters, or you can go with the number of kernels. It is up to you, or you can increase the number of neurons in the fully connected layers. This is up to you. You can make a thing and you can check on it. So that's why you will get, I think you will get only accuracy of 50 to 60%. So you can improve the accuracy with hyperparameter tuning. So I have taken one image and I have plotted it. This is how. So here I have given you a thing, right? So I have given it, this is a color image, but in reality, even though I have given you input is only 3x3, right? After input layer, I may apply many filters, right? I cannot say that that is also RGB. Mostly that will be grayscale. This is how, this is the first, in the first layer, this is how the image will be like this. And after that, it has learned some features, and after that. This is how the images are being learned in each and every filter. For instance, I have given 6 filters in one of the layer. Am I right? I think I have given 6 filters in one layer. I have given 6 filter here. The output of the 6 filter is this. I have visualized this. For a particular image, after in the first layer, this is what the output of the 6 filters. Each and every filter has identified something. You can see the difference, right? Each and every filter will be responsible for something, and it has detected some patterns. You cannot expect the RGB here because it has its own configuration, right? You can go, the depth is here is different. So this is how internally it is being done. If you increase the number of parameters, a number of filters means more filters will be there, and each and every filter will try to contribute for the extraction of the features. That's why width will increases. Mostly if you see many CNN architecture, width is high, because if you have 512 filters, the same image is scanned, or I can say that convoluted by 512 images. More or less, I can say that up to 500 features can be taken. I can say that it is more than that of the width of the height and width of the image itself. So you can get the things out of it. That's why width is high. If the width is high, one disadvantage is number of parameters will become high. That is overcome with the help of GoogleNet, but not in all the network. So this is how the internally convolution network is working. Is clear with this? Okay, this is how my accuracy is, training accuracy is 64, whereas the test accuracy is 66, because this is a random configuration I have given you. If you have worked out with, you have to work out with these things. How many filters I have to do? I cannot say that this is 6 filters is good. For instance, you can work with 16 filters and check how the 16 filters are working on it. This will give you fine-grained results too. So this is what the thing. So this I have moved to the device, to the GPU. So first time it will take time, because the GPU is not in your, not the my machine's GPU. It has to contact the Google Cloud's GPU. That's why it will take. For if you run the second instant, it will work within a minute. See here. So here it has taken, I think, 7 minutes. Okay, we will work on this. So I will share you the thing. If you want, if you have any doubt also, you can ask me. I will break, I think I will break for 2 minutes, because we have to cover more things. Then only we will give at least what is what present in that, because this is a vast topic. We cannot cover the CNN in entire thing. At least I have given the thing for you. If you have any doubts, you can ask me. Within 2 minutes, we will resume the session, within 2 to 5 minutes. If you have any doubts, kindly post it in the chat box. I will respond. So there are questions from your side. One question is, I'm using cloud GPU only, sir. I'm not using my machine GPU. If you want, you can map that also. Get the idea of it, you can use it. That is nothing but a hardware ID. You can get the hardware ID. You can map to that. Instead of CUDA 0, you have to initiate that. That's it. So the next one, LeanNet used for fully connected layer. No, ma'am. LeanNet is nothing but like that of the AlexNet only. LeanNet will contain convolution plus fully connected layer. All the image classification will have some convolution layers. Then you have a fully connected layers, because fully connected layers only give you the output, right? So this is the thing I want to say. In research point of view, Keras or PyTorch is suitable. According to me, PyTorch is suitable, but the thing is that you have to learn many things, and open source, I think if you go with GitHub and other thing, TensorFlow things are mostly present, but PyTorch things are very rare, I think so. It is present, but not as such of the things that have the implementation. For instance, if you are saying that plant disease classification, you have the problem like this, you have the data set also for this. If you want the code for that, it is not that you have to write all the codes in the deep learning. Only thing is that appropriate use of the coding is the skill in the deep learning, but you have to know what is the internal working. That is the wise way of working with the deep learning. So PyTorch will have less thing, because it has some complexity, but because of complexity you can get the result also, good results also. But TensorFlow, I can say that for student point of view, TensorFlow is enough. If you go with the research point of view, kindly go with the PyTorch. We can use, yes sir. So cloud GPU is provided by Google Cloud is providing you, because COlab is nothing but a virtual environment that is provided by the Google, right? So they are providing the GPU support for you. That is what I am using now. So for machine GPU, if you have good machine configuration, mostly in i5 10th generation, you have NVIDIA support, right? You can go ahead with that. But if your data set is, for instance, I can say that if your data set is for medical image processing, it is better to go with your device GPU, because this has more processing power, right? Because cloud for free usage, that there is a limitation. For free support, there is a limitation. So if in our college there is a GPU support, you can go ahead with that GPU support, sir. In our college there is a GPU setup for supercomputing aspect. You can go ahead with that also.
Ma'am,
Yes, ma'am.
கும்படி
Yes, ma'am.
மேம் இப்போ நான் மெடிக்கல் இமேஜ் ப்ராசஸிங்ல பண்ண போறேன்.
ஓகே மேம்.
ஸோ இப்போ இதுக்கு மெஷின் ஜிபியூ அப்படிங்கிறது இப்போ நம்ம யூஸ் பண்ற சிஸ்டம் சொல்றீங்களா?
ஆமாங்க மேம். இப்போ லேப்டாப் இருந்ததுன்னா உங்களுக்கு அதுலயே சப்போர்ட் இருக்கா இல்லையான்னு உங்களுக்கு தெரியும். ஜிபியூ சப்போர்ட் NVIDIA கார்ட்ஸ் இருக்குங்க மேம். அந்த NVIDIA கார்ட்ஸ் இருந்தா அந்த NVIDIA ஐடியை நீங்க பிக் பண்ணிக்கலாம்.
ஓகே ஓகே.
அத பிக் பண்ணிட்டு 2 டிவைஸ்ல இருக்கு பாருங்க, அந்த ஐடி கொடுத்தீங்கன்னா முடிஞ்சது, அவ்வளவுதான்.
மேம் இதுலயே எனக்கு இன்னொரு டவுட் இருக்கு. ஸோ இப்போ மோஸ்ட் ஆஃப் அஸ் இப்போ நம்ம நெட்ல படிக்கும் பொழுது எனக்கு எல்லாமே டிஃபால்ட் டேட்டா செட், அவங்க ஏற்கனவே இருக்கிற டேட்டா செட்டை வச்சுதான் நிறைய சாம்பிள் கோடிங்ஸ்லாம் கொடுக்குறாங்க. ஸோ இப்போ நம்ம ப்ரீடிஃபைன் இப்போ நானாவே ஒரு இமேஜ் அப்லோட் பண்றதா இருந்தா அதுக்கு ஏதாச்சும் கோடிங்ஸ் இருக்குங்களா?
நீங்களாவே இமேஜா கொடுக்க போறீங்களாங்க மேம், இல்ல உங்களோட டேட்டா செட்டை கொடுக்க போறீங்க? கரெக்ட்டா?
டேட்டா செட் கொடுக்க போறதுக்கு.
ஓகே. இப்போ நீங்க அதுக்கு என்ன பண்ணலாம்னாங்க மேம், இப்போ ஆர்கிடெக்சர்ல நான் சொல்ல போறேன். இப்போ நீங்க அந்த மாடலை வியூ பண்ணிட்டு எந்த இடத்துல உங்களோட இது மாறுதுன்னு பார்த்துட்டு அந்த இடத்துல மட்டும் சேஞ்சஸ் பண்ணீங்கன்னா போதும். ஸோ அதுதான் இப்போ அடுத்தது பார்க்க போறேங்க மேம். நீங்க அதை பார்த்துட்டு சொல்லுங்க, அது உங்களுக்கு சாட்டிஸ்ஃபை ஆகுதா இல்லையான்னு சொல்லுங்க. தென் ஐ வில் கிவ் யூ த திங்ஸ் ஃபார் தட்.
ஓகே மேம். ஓகே மேம். தேங்க் யூ மேம்.
ஓகே மேம். So for object detection, it is YOLO, sir. YOLO have many version. You can go with the YOLO. YOLO is the best known object detection. Any more queries? How to use NVIDIA ID in DL? That's it, sir. In the two device, you have a code here, right? You have a code here to two device, right? See here, two instead of device, you have to give NVIDIA ID. That's it. Here you have, I have given you the device, right? See here, my device is nothing but this thing. Since you can map these things with the, even you can run with the Jupyter notebook itself. If you go with the Jupyter notebook, you have to install all the things like Torch and other thing. But if you run with the COlab, it is very easy because already they have given the support packages for deep learning and machine learning. It is used in edge device. Yes, sir. For this only, I am having an idea on that. In order to go with that, you have for smartphones, this computational intensive and memory is very difficult. For that, you have a mobile deep learning. If you go with that, this is general deep learning. There is a different aspect called mobile deep learning. The models are very compressed to go with the edge devices like smartphone. You cannot push these aspects into your mobile device. If so, your device will be hanged. So for that, there is a mobile thing. In that, you have a Flutter and other thing. Hope you have heard the things like Flutter and other thing. This is how mobile application development platforms has been developed with respect to deep learning itself. And now fast AI is there, that also provide you the computational less deep learning aspect for the smart devices. Yeah, you can use YOLO and whatever you want, you can use it there. But there is a different aspect of mobile deep learning. This is generalized deep learning. You can use with these things. You can use it in the smartphone, but there is a different package for that. You cannot go with these package. Core is this thing. You have same convolution 2D and other aspect, but the things are different. Sir, I will give you a demo in the end of the session how to identify NVIDIA in the laptop. Mostly if you are with i5 and above 8th or 10th generation, it will support NVIDIA. So mostly if the cost is above 50 plus, I'm very sure of it, it is supporting NVIDIA. Okay, sir. I will have at the end of the session, I will give you what is the current trend in this area of deep learning with respect to, because if we are clear with the basics, then we can go ahead with the current trends. Okay, the same thing we are going to use only in a compressed manner. Here there is no need for to go with all the n functions and like things. Within a single function, they will do all the things. That is how they have designed for the mobile deep learning. Even mobile deep learning is a separate course. This is blooming well. If you have time, have a look on it. Sir, I am not very confident in the spec of laptops. As far my lap is concerned, it is i5 core i5 10th generation. It is supporting NVIDIA. I am not expert in the hardware aspect. If so, I will check and tell you. Is it fine, sir? Okay, sir. So we will move on to the next thing. So the next aspect of this is architecture. Okay. So this is the thing. So many of you have asked. We have know how to customize our model. Now we are going to have a predefined model. We have seen popular CNN models like VGG, AlexNet, ResNet. So we will have a look on it and work on it. So because the time is only 45 minutes, I want to give a more thing on that, because I will share you all my presentation things. You have a look on it at your earliest time, because if you have a look on it, then we will get the things out of it. Okay. So these libraries, hope you know these things. Then again, this CUDA 0, as usual for GPU. This comes the important thing. See here. For instance, you are going to use what I think the network here is VGG. Assume that you are going to use VGG net. So in that, what you want? So VGGs, we have a input data size of 224 cross 224. If it is an RGB, by default it is a 3-channel. So, but if you go with the CIFAR data set, see here, I'm already told that I'm using my CIFAR data set 10. Okay, this itself have some problem, right? So ma'am has asked, right? For instance, if your image is 40 cross 40, but my network is going to use 224 cross 224. So first you have to transform your images according to the model. This is the first step. If you are going to use your own data set, you can use your own data sets. Now the CIFAR 10 is not fit for my VGG, because VGG need data, I mean image of size 224 cross 224. Now it is available only in 32 cross 32. So first step, if you have your data set, for instance, if you are having a medical image data set, if your size is like 512 cross 512, just you have to transform it into the size that is fit for the model. That's why I have already told you, if you know the inner working concept only, the coding aspects will be very easy, or else it is very difficult to learn the deep learning itself. So first I am going to have a transform underscore train. In that I am going to random resize, transform dot random resize. If you give the shape alone, it is enough. That's it. Then two tensor, as usual, we have seen this. This is very important. This normalized, right? So there are 3 channels. Am I right? As of now, I am working on RGB image. There are 3 channels. These are nothing but standard deviation and mean. The thing here is that I am going to have a equal distribution of these RGB filters. So that's why I have given a mean of 0.5, and standard deviation will give you the equal spread. I think you are getting the point. I think so. So if you give the mean of 0.5 means I'm getting the averaged RGB values in that transformation. See here, I'm going to normalize the things. Am I right? Hope you know what's the use of normalize. If your pixel is of 124, 35, 45, if you're going like this spread is high, then you will have a overfitting. Outliers will be there. Then the model will not learn all the things. So you have to normalize your data. In order to normalize, the apt thing is that mean and standard deviation. That's why always statistics and probability math is the core background behind it. So I have given standard deviation for each and every channel. I have to give the standard deviation. So first is the standard deviation of 0.5. If you take a bell-shaped curve, the mean is 0.5 and the spread from the each side is 0.5. I have equally distributed these things. So in order to normalize my images into things within 0 to 1. Same, this is done for training data. This is done for test data. So while you are downloading itself, you are going to transform it. See here, transforming these things. So if you are using your own data, for instance, if you have your own data set, so you have to know which model you are going to use. For instance, if you are going with VGG, you should know what is the input size that a VGG model will take. As we have already learned that VGG will take 224 cross 224, that to 3 channels. So you have to give only the color image, not grayscale image. Please have a look on it. This is what the spec that the VGG will work. So you have to modify your data like this. So I have done this, made this transformation, then these things are as usual. Things are already present, then train equal to true. Then number of classes 10. For the base thing I have given batch size equal to 4. For basic thing I have given, I will not execute the thing, I will explain and go ahead. Then data loader, from I have loaded the training data and I have shuffled this. These things we have already seen in the previous thing itself. Then I have iterated and I think I didn't have any output, so I will run and show you. So this is pre-processing. I can say that this is how you have to pre-process. In order to pre-process, you should know which model I am going to use. Then this is loading of data set. Then next one, number of classes. As usual, CIFAR 10 has 10. I have taken batch size as 4 because for simplicity, I have gone with this. I have gone with the data loader. Then I am going to iterate with each and every images in that. So this is 224 cross 224. Same thing I am going to, so have a look on it. This is size is 224 cross 224. Because original image is 32 cross 32. If you go with the CIFAR 10, original image is 32 cross 32. Now you can check here. It is taken 224 cross 224 into 3, fit well for my VGG. And since there are 4 channels, 4 images in a batch, that's why 4 here. If you take a particular item, this is the output. This line is the output for, this is the output for this code. And if you take a particular thing, then 3, 224, 4. Then the item in that, if you have taken a particular image in that, the 4th item I have taken, the index of it, that's it. Next I have same thing. I have taken this, I have to convert this into NumPy and I will show it in a grid. So the function here is, I have written this in a function. So this is what. So I have taken 4 batches, in 4 batches in each one having the 4 images. So one thing I want, we have already seen this, right? So have a look on it. This will be very, I think this is not present, it is updated, I think so. In docs, go with the docs, PyTorch. So go with the models, torch.models. So this is the torch.models. So if you go here, these are the models that are present in here. So as of now, we have seen up to ResNet, you have wide ResNet and MNASNet. So each and see AlexNet, BGG, ResNet, ResNext is also there. See here, MobileNet is also there. So GoogleNet is also there, Inception V3, DenseNet, and these are the available already pre-trained models are present. You can use on it also. So for instance, if I'm going to VGG, so if you go with, so now they are not providing the code for you. If you want, this application will be given for you. In the earlier days, they will provide you the thing. So if you go ahead with this, okay, so from this only you can go with this. So if you use VGG 11 with the batch normalization, this is the error. They have already told that this is the error rate. Then if this is error rate, have a look on it. Is this fine for me so that I will get the accuracy? So people are saying that I'm getting 98%, 99% accuracy. It is a meaning that they are saying on their own. Model will not have given anything like that, because already it is showing that it will give you 8.5% of error. So it is possible to give 92 or 93% of accuracy is enough. With some, I cannot say that always it will be less than that of 98 or 99. But if you have done some hyperparameter tuning and model modification, surely it will give you the things. So next one, so this is, I have imported the models from the Touch Vision. See here, VGG equal to model.vgg16 I have taken, and batch normalization I have taken. So there are many models there. Refer in the net and you can use on it. Now, if you print the model, you will get the things. Whatever we have learned in these things, you will get the things out of it. See here. So BGG, we have seen in the morning class, right? You have a first convolution layer, which is of 3, kernel size of 3 cross 3. Because if you take this is 64, is nothing but there are 64 filters. Then 3 cross 3, you have used stride of 1, padding of 1. Then it has used batch normalization, leave it. Then it has used ReLU. Then it has taken, so the output of this layer will be surely will be 64. Then again it has used 64 with kernel of this side. Then it has used max pooling with these things. So with this you can visualize these are the, see here, this is sequential. So if you want to have a research aspect of you, for instance, you want to use VGG for your research aspect, but your VGG model is providing you only 70 to 80% of this. Just copy this aspect, make some changes in this, and you create your own model and have a look on it. That is what enough in deep learning. So only thing is that you have to visualize the things and get into that. So I have already told that there is average pooling, right? In the VGG, there is an average pooling. So this will have in the linear layer, this is what the input features. And you have, they have placed ReLU, dropout and other things. And they have placed the 4096, again 4096. We have seen this, right? This is 2058 is nothing but output from my convolution 2D. This if I go with max pooling, I can say that after this, what will be the output will be taken as input. The input here is 25088. Okay, the output here is 4096. After, because it has 4096 neurons. Similarly, you have another fully connected. For fully connected, you have to call a function called linear. Next, you have a 4096 fully connected. Then you have 4096. The output features here is 1000. So if you see here, here it is going to provide you the 1000 classes. This is what the meaning, am I right? As a final, this is going to give you the 1000 classes. But for me, I am having only 10 classes. Am I right? This is how I has been planned in this thing. But BGG, see here, BGG is done in such a way that it is going to have multi-class classification of up to 1000. That is the meaning out of it. But now this VGG has to perform only multi-class classification of 10. So you have to make a rechange in that. That is what we are going to do. Some changes only we have to go with that. So if you want to print the, just I have printed this. Same thing, I have taken the feature. In that feature, I have printed the 0 just for visualization. That's it. Then if you want, you go with the classifier of 6. You will print here the classifier. This is the classifier module. If you go into string, you have to print this. Always go with always you have to print the model and see what is the output we are going to give. I don't need 1000 classes. My class now here is nothing but 10 because if our 10 dataset supports only 10 classes. But VGG model is a generic model, right? It is able to provide multi-class classification of up to 1000 classes. But what happens if I give only the 10 classes input? It will not work fine. What happened other 990 classes? You cannot say that give it as 0. So you have to provide some modification to the already given module. The things see here. So from this, the output feature is 1000. That is what the after printing only you will get this. In this model, 6th classifier is the output, a linear layer, which gives the output of 1000. So this is the final feature, right? Now I have to modify it. Okay. Now how I can modify it? I will take all these things. I had in the classifier, these are the children. If you take this works like XML format. If this is a head, these are the children. I will take all the thing. If you give -1, it will neglect. Leave these things. Okay, so all these things will be copied. These things are as usual. I don't want to change any other thing. If you want to change any other thing, you can give the code like that one. See here, I have removed these things. See here, list. I have taken all the children except last one. In the last one, what I have given, see here, extend. Hope you know What is the use of extend function in the list? This is a list. Extend means it is going to append another list with it. What it is going to? Linear function. Okay. What is the final in features? Final in features are these things. Okay. How many classes? In feature, final in feature, it will take these things. Here the number of classes is 10. So this is the thing. Now I have changed my classes from 1000 to number of classes. This is stored in a list called mod classifier. Now this is passed as an argument to nn dot sequential, because my method is nn sequential here, right? See here, this is nn sequential. Always this is nn sequential only. If you are going to write your custom thing, you will go with nn model equal to nn dot sequential. Even VGG also written like this only. They have stacked many things in that. So you are passing this as an variable, I means that variable length argument, arbitrary argument. If you give star, that is an argument, arbitrary argument in Python, am I right? If you give star, wait, I have left where? Okay, here. Star mod underscore classifier, this will have the updated classifier thing. Now I have passed these things to the, you can visualize this mod classifier. This is a list now. See here, this is a list now. You can see everything, whatever present here is taken in this thing, and this is gone with here. It will contain, see here, in class classifier. These things are taken as items of the list. See here, this is taken as another thing. And now if you go with the last thing, if you see the out features, in the last one, if you see the out underscore features, see here, it is changed from 1000 to 10. Hope you got this thing. This is how you have to use for your dataset. If your dataset contains 25 labels, you have to change like this. Now it is changed. It has to be updated in my classifier, right? So I have to pass this using sequential. I have to pass this to sequential. I have done this. Now you print and see your VGG model. Same thing, I have not done any. If you want to change anything, this is how you have to change it. Very simple method. See here, now it is 10. So this is how you can custom your thing and go ahead with that. So next you go with the training. So I have increased the batch size. Same thing. I think these things are very familiar for you. 2 devices and other thing I has given. This is evaluation part. So data loader. Hope you got these things right. Train set and test set. Then evaluation part, same thing. Whatever the code I have explained to you in the previous thing, the same thing. You have taken the maximum. Since it will return the probability mass, you have to take the largest mass out of it. That's why torch.max, and get the label out of it. Out of that label, you are going to count on it, and how you are going to have accuracy is nothing but correct by total. That is what it is going to return. Then as usual, last, I have pushed this to my GPU, that is to cloud. Then I have given the cross as cross entropy SLRs. Now I have used, instead of Adam, I have gone with the stochastic gradient descent. You have many optimizing algorithm, AdaGrad and other thing. Stochastic gradient is a random classifier, random optimizer. So it is not under the control of how to take and work on it. This is a random classifier. So this will work fine at some time, will not work sometime, because this is a random classifier, random optimizer. So now I have pushed the things. I have calculated the loss. Always, if you note that if you are going with the probability mass, always go with the cross entropy. Simple thing. Just you have to call the function in the NN module. Then I am going to have this test and train accuracy. That's it. I have given. So I think it will take for a while. Even though I have given max epoch equal to 1. See here, number of iteration here is, I have given something so that only it will learn something, right? So see here, so the next one. So this is very important. So here in the training, you are going to learn each and everything on your own. Am I right? Even though the model is, you have taken the model, your all the weights are again learned from the convolution to fully connected. See here, I think we have seen there are 23 million parameters. So it has to learn 23 million parameters. So this is a difficult task, right? So instead of going like this, why can't I have a pre-trained model? That is what the next thing. Same thing, see here, instead of if you give the pre-trained equal to true, they have already trained to some aspect and saying that up to this is a pre-trained module with all the weights updated to that. The only thing you have to go here is that you have to go and change with your aspect of input and output. So instead of going to train weights on your own of about 23 million, I think it is 23 million parameters in VGG, you can go with the pre-trained model. This will reduce the computation. So I have taken a batch size of 6. Okay, I think it is running behind. So I have given requires grad equal to false because I don't want the gradient to move here, because there is no back propagation at all here. Because already model is trained, all the weights are updated. I am assuming that that is the optimal thing for me. You can check with that. If not, you go with the previous thing. It is always wise to go with a pre-trained model. If the things are not working fine for you, you can go with the non-pre-trained model. Then as usual, I hope this has run. Okay, this is running. So then as usual parameters, then I have pushed to the device, then cross entropy, same thing. Then accuracy, I have plotted here. Okay. So these same thing, instead of going to have with the VGG, I am going with the pre-trained model. Because of that, you have changes in this. You have changes. You should give this statement. This is very important. This one. Gradient equal to false. Param.require gradient equal to false. This is important. So the next one, you can create a copy of your model. Okay, in order to go with that, you have a library called copy. You can make a copy of your model also. You can start your model training from that aspect. You can have the checkpoint also. You can go ahead with those things also. So in that, see here, up to this, these are the same. So up to here, these are the same. So here you are comparing. I have taken a variable called minimum loss. I'm saying that minimum loss is 1000. If my minimum loss is greater than that of my loss dot item, always this will be greater. Am I right? Now my minimum loss is nothing but loss dot item. So up to a checkpoint, your model will have a decreasing loss. You can observe this in this execution. See here, it is 2.29. Again, it is 14.46. It will be decreasing, right? It will be decreasing up to some point, and it will go into increasing more. So up to decreasing aspect, I can take a copy of it. Am I right? So see here, up to 2.26, this is decreasing. Now it has increased. So up to this point, I can take a thing out of it. So for this only, we are going for a copy of this. In order to do that, what you can do, copy.deep copy, you take the state of it. You take the state of it, okay? Then after that, what for next iteration, since we are giving for next epoch, since we are giving the number of iterations and epochs, you can give the more number of epochs or more number of iteration, or I can say that for the next epoch, you can start with this model. So up to this, if you know that this is the model and this is the loss, after that only there is some gradient loss. I think there is a gradient loss only. Because of that, the loss is going to increase. So on that only, you tune your parameters. If the kernel is being improved, this will be very useful for you. So after that, so you have saved in this. Then what you have done, you have deleted all the inputs, labels, and outputs, and you have freed your CUDA also. Then you are going for the next iteration. So you don't want the remaining things. You are going to have the model up to which the loss is perfect. Take a copy of it. Deep copy means you are taking a copy of it. Shallow copy is nothing but a sharing. If you take a deep copy of it, you are taking a copy of it. The original copy remains the same. Whatever the changes you are doing in your copy, this will be reflected. So your VGG net will not be reflected. Please have a look on it. That is what the deep copy. So this is how you can optimize your working aspect. So I think this will take a minute to. So this is RESTnet. As usual, if you are using pre-trained, I'm using RESTnet 18. It means that there are 18 layers. If I'm going with the pre-trained layers, I have to give it as true. Very simple thing. I have to give param.required grad equal to false. Then I have to check the number of features, right? Since the number of classes is 10, I have to set these things. Okay. Next, as usual, entropy, cross entropy. This is optimization. Same, I think I have copied the same code. Only thing I have changed. This is deep copy, same code. Nothing is changed here. Same inception. Just you have to call this. If it is a pre-trained, go with this. One thing I want to insist here. I have already told that the salient feature of the GoogleNet. So if you see here, if this is not given a name as GoogleNet. Now GoogleNet is also available. Actually, it is called as Inception v3. As I have already told that GoogleNet has many features like 1x1 convolution. The other important salient feature is auxiliary loss. So intermediately you can take the loss and you can back propagate it, and so that you will reduce the number of parameters. So in both the thing, because intermediate itself you will take the you want to give the loss, right? In that case also your number of classes has to be 10, not 1000. Because this will have, I don't know what is the number of classes in this thing. So in this case, I have to say that the number of classes is 10. So for that only, auxin feature equal to the auxin inception dot aux logistic dot fc dot in feature. I have taken this. I have made this as a linear layer with the whatever the neurons they have given. Okay, then with the number of classes as 10. This one. Next, I have to, this is auxiliary thing. Next, I have also give for the linear layer. Am I right? In the last layer. If I, for instance, if I have taken the auxiliary loss, there also I have to specify the number of classes. If it is, I have gone up to the end of it. So there will, so I have gone up to the end of the fully connected layer. In that case also, I have to give like this. So these two, there will be two modification if you are going for the inception because of the auxiliary loss, then as usual final fully connected layer. Okay, then transform. Here the transform, hope you got these things right, because if inception is going to accept only 299, you have to crop these things to 299, then as usual, things are as usual. Nothing is different here. Same code. I'm saying that, right? If you understand this one, if one time code is enough, you can go with all the other things. Same code I have used here. That's it. I think so. The thing is that you have to visualize your model, get what is present in the model, change according to your convenience, and make a note of it. This is very essential thing. You have to have a look on it. So another 1 or 2 minutes, if you have any queries, you can ask me, because it is taking time. Okay, ma'am. Ma'am, someone has asked me that if I have my customized data set, how can I go with that? Have I addressed your issue, ma'am? I forgot the name of her. நீங்க ஒன்னு சொல்லிருந்தீங்களே இமேஜ் ஐ திங்க் மெடிக்கல் இமேஜ் ப்ராசஸிங் நான் பண்ண போறேன், இமேஜ் கிளாசிஃபிகேஷன் ஆர் இமேஜ் ப்ராசஸிங் பண்றப்போ என்னோட கஸ்டம் டேட்டா செட் எடுக்கிறப்போ நான் எப்படி இது பண்ணணும்னு கேட்டிருந்தீங்க. இஸ் இட் ஐ ஹவ் கிவன் யூ த ஓவர்வியூ ஆன் ஹவு டு ஒர்க் ஆன் இட்? ஓகே, at some other time if you have any doubt you can ask me. For a minute you can give me your queries so that I will answer that, so that I will go into the next part. we will go into the occultation experiment. It is very simple. Just you are going to visualize which neuron is fired and which neuron is not fired. That's it. This will not contribute much to the research, but it is good to visualize the thing. What is happening inside is exciting. Is there any doubts? I will share the code with your coordinator, get the things from that. So this PyTorch code is very rare in some part. So this is the basic code. You can get the things out of it. You can work on any data set or anything. So that's what I can say that. So in the research point of view, I want to give you something on it. Because of lag in time, I will give you. Go with FastAI. So FastAI is nothing but it is mostly with respect to PyTorch only. I will give you a simple example though, so that I think I have a GitHub FastAI mail. Okay, I will go like this. This will be useful for you. Create own data set. Try to experiment this. This will be very useful. Own data set using Google Image. And image classification. I think n number of things are present. Okay, this will be fine for you. I think so. So assume that I have in the morning I have told you, right? In the morning I have told you that you are having the problem. You have the problem, right? You want to find, you are having the problem and you are able to provide the solution for that, but you are not having the data. For instance, if you take the image classification itself, it is rare to get most of the medical images, right? So it is only some of the data sets are present for that. For instance, I am saying that I have worked with a simple example for my student project yesterday. For instance, you have based on the nail images. So nail is also பழைய காலத்துல சொல்வாங்களா நெயில்ல கோடு கோடா இருந்தா some vitamin deficiency. So அந்த மாதிரிலாம் இருக்கலாம். Some micronutrient deficiency will be there that can be predicted with the help of nail images. So அந்த nail image நான் எங்க போறது, எந்த ஹாஸ்பிட்டல்ல போனா nail image கொடுப்பாங்க, அது மாதிரி ஒரு data set இல்ல. There is a transit biometric data set. Is there any issues, ma'am? If there are any doubts, you can ask me. Okay, I will proceed with that. So it is very difficult that too வேற ஏதாச்சும் ஸ்கேன் இமேஜ்னா கூட நம்ம வேற எங்காச்சும் கெட் பண்ணிக்கலாம். நெயில் இமேஜ் கெட் பண்றது ஒரு ரேர் இதா இருந்தது எனக்கு. ஆக்சுவலி we struggled a lot. There is a biometricல நம்ம வைக்கிறப்ப அந்த நெயில் இமேஜ் மேல அந்த கேமரா ஃபிக்ஸ் பண்ணி அந்த எடுத்தது தான் ஓப்பன் டேட்டா செட்டா இட் இஸ் அவைலபிள். பட் அந்த இதுல எல்லாத்துக்கும் நம்ம போய் இது பண்ணிட்டு இருக்க முடியாது. பட் there is an optical resolution also here because இந்த பயோமெட்ரிக்ல ஆப்டிக்கல் illusions இருக்கும். அப்போ உங்களோட blood flow எல்லாமே இதாகும். அதை வச்சு என்னால I cannot go with a precise image classification. So what we have done, this is very interesting too. So அப்ப என்ன பண்ணோம் அப்படின்னா just go with the கூகுள்ல போட்டு கிடைக்காத எதுவுமே கிடையாது. So கூகுள்ல ஜஸ்ட் நீங்க இப்போ ஃபார் இன்ஸ்டன்ட் யூ வாண்ட் டு ஃபைண்ட் விட்டமின் B12 டெஃபிஷியன்சியா இருக்கிறப்போ உங்க நெயில் இமேஜஸ் எப்படி இருக்கும், ஜஸ்ட் கூகுள் இட், யூ வில் கெட் n number of images, right? Get those images and save it. Just save பண்ணி ஃபோல்டர்ல வச்சுக்கோங்க. அதே மாதிரி அயன் ஆர் சம்திங் இது மாதிரி எல்லாம் இது மாதிரி எத்தனை கிளாசிபிகேஷன் பண்ணணும்னு நினைக்கிறீங்களோ 10 classes ஆர் 15 classes, இட் இஸ் அப் டு யூ. ஸோ இதெல்லாம் எடுத்து வச்சுட்டு நீங்க என்ன பண்றீங்க அப்படின்னா சிம்பிள் பைத்தன் கோட் இருக்கு, இல்லைன்னா ஜாவா ஸ்கிரிப்ட் browser capability தான் கூகுள் குரோம்ல works fine. ஸோ இதுக்கு நீங்க பாத்தீங்கன்னா ஆர்டிகல்ஸ் நிறைய இருக்கும், நீங்க ட்ரை பண்ணி பாருங்க. திஸ் வில் பி இஃப் ஸ்டூடெண்ட் உங்க ஸ்டூடெண்ட்ஸ்க்கு இது மாதிரி கொடுக்கலாம். லேப் பேஸ் எக்ஸ்பெரிமெண்ட்டுக்கு வந்து டேட்டா செட் தான் கொடுக்கணும் அப்படின்லாம் இல்லை. தே கேன் ட்ரை வித் 100 images, இட்ஸ் எனஃப். இஃப் தே லேர்ன் த இன்டர்னல் திங், தட் இஸ் எனஃப் ஃபார் them. லேர்னிங் ஆஸ்பெக்ட் இருந்தா போதும், அவங்க எவ்வளவு பெரிய இதா இருந்தாலும் ஐ மீன்ஸ் ப்ராஜெக்ட்ஸா இருந்தாலும் தே கேன் கோ வித் இட். ஸோ அப்போ என்ன ஆச்சு அப்படின்னா, ஐ ஹவ் டேக்கன் 100 இமேஜஸ். அப்போ அதில் பார்த்தீங்கன்னா ஒரு 50 இமேஜஸ் வந்து விட்டமின் B12 ஃபார் அதர் ஃபார் அயன் அண்ட் அதர் ஃபார் அதர் டெஃபிஷியன்ட் திங்ஸ். ஸோ யூ ஹாவ் okay. Sorry for speaking in Tamil. I think it will be effective. So what I have did here is that I have taken images, say 10 to 15 images for each classes I have taken. So this website will give you how to get the things. You can go and have a look on it. In that, the latest improvement, I can say that you can get the URL of all the images with a single line code. These are the line of code. It is essential. Just you have to open the console. If it is in a Google, I think I am in the presenting mode. Go and click here. In that more tools, you have a developer tools. In the developer tools, go and click the console. Okay, go and click the console. In that console, just click the, I think I have to go here. Okay. First, for instance, I'm saying nail images, fingernail deficiencies. Okay, images. If you go like this, this is the thing you will get. Go and click this. In that developer tools, you will have a console, right? This is the console. Just copy and paste this. Just copy and paste this line. You have to format very clearly. This colon has to be given correctly. Okay. Then you give that a file will be downloaded. Okay. Your file will be downloaded. That file will contain. So make sure that because of that, there will be security issues also. So while you are doing this, make sure that because if you are changing your console setting, if you are going with any banking transaction, make sure that your cookies are not going to access these things. Okay. This is an issue here. Kindly have a look on it. So if you are going like these things, go with a different browser. This is my advice. So what you can do here is that you will get a URL of all these things. Okay. So now you have a file that contains the URL, for instance, for 1,000 images, because Google can give you more than 1,000 images for a thing. It will automatically fetch everything. So there is a package called FastAI. This is very interesting. You need only a small amount of code. I think 10 to 15 line is enough for you. So I have created a folder. This is it. I'm doing all these things in the COlab itself. There is no need for to create anything. And just you are going to create a folder in the COlab. You know how to create a folder and other thing. Just you are going to push the things in that. You can update, you can upload the data into the Google Drive in the COlab notebook folder. Hope you know how, if you are working in the COlab, a folder will be created in your drive in the name of COlab notebook. In that, upload your folder. Okay. After that, mount to your drive. Hope you know how to mount you in this drive. It will ask for the security authentication. After doing all these things, see here, you can download all the images. Now you are ready with your data set. That's it. You have got all the data sets. See here. But the size may vary. If you want, you can go with the transform. That's it. Since the touch is producing. So if you want, you can go like this. But in FastAI, these are, FastAI is also called as have transform too. Whatever the size you want, you can go with that. For instance, I'm saying that if I'm using VGG, the size is 224. I can go and call this get_transform size equal to 224. It will work fine. It will transform your image into 224 cross 224 with a size with a depth of 3. Whatever you have done is done here. So same things are done here. Now your image, your data set is ready. So simple thing, just you train the model. So in calling the model, just CNN_learner, you have to give your data model.ResNet. Now if you are using the ResNet, that's it. What is the metric based on it you want to learn? Error rate. That's it. So if you want how many cycles I have to, that is nothing but epochs, right? In order to give the epochs, you have to fit underscore one underscore. There are many functions on it. If you want, you can go and have a look. Even the COlab is supporting fast AI. Now COlab is supporting fast AI. If it is not supporting, give :pip and install fast AI. That's it. Then you can interpret the classification. Okay, you can get the loss out of it. What is the top loss for each and every classes? You can get all these things. See here. You can get the confusion matrix and what's the accuracy. Everything is plotted. If you count here, at least 10 to 15 lines. Simple lab program is here. You don't need any data set or anything. If you want, you can add your image for a while. Now we are going to create a data set. It is enough if you have a medical image of 500 images, more than enough, because it is very rare, right? So these images are very rare. So if you have a problem, if you are ready to provide the solution, these are some of the approach you can work on it. Okay, now fast AI is working. This fast AI will give you an intuition to work with the edge devices like smartphone. So now this fast AI, you can made it as an APK and you can develop it as an app with the help of Flutter, and you can use it in your smart devices. So this is how deep learning has evolved. Not only with, you are always thinking this is a computational intensive, you need CPU, GPU and other aspect. This is not at all a thing like that. But the thing is that if you know the internal working, you should know everything. If you know the internal things only, you will make the changes, right? See here, I am going transform here. I don't know why the 224 is given. If not known, this is not at all useful here. Because we have learned this ResNet, right? We know that the size of it is 224. That's why it is 224. Can we change it as 200? Will it work? This will not work. That's why internal working model is very essential in order to work with the deep learning. This is one thing I want to share with you. If you don't have any data, don't worry about it. Google is providing everything. Google image is advanced search with that. You can go and search on it. So this can be done either with JavaScript or with the Python. So this is with respect to Python. You have n number of APIs. APIs are there to provide you how to fetch the URL of all the search result. So even the browser itself providing those APIs, you can use those APIs and work on it. Now the trending thing is that fast AI. So go and have a look on it. And many resources are available in this docs page also. In GitHub also, many things are present, but it is developing. I think this will become a boom in next 2 to 3 years. I think so. Because if 5G is rolled out, your smartphone will become an intelligent device. So in order to go with that, they need a mobile deep learning. In mobile deep learning, fast AI is one of the aspect in that. Hope I have given you some insight on that. Is there any issue? That visualization is not an important aspect, I think so. If you want, I can share the thing with you. You can have a look on it. Occlusion experiment. If you are, I want to know which neuron is fired and how it can be used. So time is 4. I have 2 minutes. If you have any doubt, you can ask me. Is these things fine for you? Any doubts? Yes, ma'am.
How to enable CUDA in your device, ma'am?
Okay. Go to edit. Ma'am, is it visible for you?
Yes, ma'am.
Okay.
It's visible.
Go to COlab, ma'am. In COlab, go to edit menu. In that you have a notebook setting. In that you have a hardware accelerator. NAND, CPU, TPU. Now TPU is also working. There is a simple code for that working with the TPU. Just click CPU. That's it. Save. That's it, ma'am. After that, if you want to push your data to the thing, just give it like this. 2 and the CUDA name. That's it. Now here the device will have the CUDA name. That's why I have given here. I think it is. See here. My device is pointing to CUDA 0. That's why I have given you thing. You have to know what is the name of that. We have seen in the previous class, right? If you want to print the device itself, it will show you what is the name of the device. If you want to, what is the type of name of it, mostly it is Tesla. Tesla based GPUs are given because Tesla is number one in ICs, right? Tesla is the greatest manufacturer of ICs. That's why. Ma'am, is it fine for you? Is it okay, ma'am?
Ma'am, you told about COlab. That is, I'm asking about NVIDIA, ma'am.
Okay. For NVIDIA, as of now, I have taken my GPU. I cannot show me. If you want, I will give you the detailed video is there. I will forward you, ma'am. Through your coordinator, you can get.
Ma'am, thank you. Ma'am, can you share your mail ID?
Okay. I think this is fine for you. If any misconvenience or anything, I'm sorry for that. I'm very thankful to you for your active participation because I'm very interested in giving you more things. Really, I'm happy with that. I'm very thankful to Shanti ma'am for giving this opportunity. Thank you, ma'am, and I'm very thankful to all the participants.
Thank you, Tamil. So, on behalf of all the participants and on behalf of myself, I thank today's resource person, Ms. K. Tamil Chelvi, for exploring the basics of deep learning with a different case study along with hands-on session. She also explained clearly the architecture of CNN and its variation.
Ma'am, they're asking the COlab sheets. If you want, I will share everything with your coordinator. You can get it from her. All my materials will be given for you. You can get everything from your coordinator. I will share the link.
Okay, we will share all the material to the participants through mail.
Okay, ma'am. Okay. Thank you, ma'am. Thank you, everyone.
Thank you all. Today there is no session. Again, we will meet on Monday.